Okay, this time we're going to check for current. I have the same setup as I did for when we were checking for voltage in this circuit. I have the same simple series circuit here. I have our positive power supply coming in, going to this orange jumper wire. The orange jumper wire goes to the center pin of the slide switch, and the far right pin of the slide switch is in connection with the anode of the blue LED. And then the cathode of the LED is in line with this 1000 ohm resistor, and the other end of the leg of the resistor is in line with the negative supply here. So in order to check for current, I need to remove this LED out from the circuit, and all I'm going to do is I'm going to turn it and put the anode of the LED off on this point here, and I'm going to keep its cathode connected to this resistor here. So right now the LED is out of the circuit. The circuit is open between the switch and the LED here. And what I'm going to do is I'm going to put a jumper wire here so I can attach my probe from the multimeter. I'm putting it here because that's where I took out the anode of the LED from the circuit. So now, in order for me to make a connection with one of my probes from the multimeter, I needed to put this jumper wire here. So now I'm going to take my red lead of my multimeter, my test probe, to this orange jumper wire, and I'm going to take the black lead of my multimeter, and I'm going to attach its probe to the anode of the LED. So right now I've got the LED out of the circuit, and in between where the circuit is opened, between between the far right pin of the switch and the anode of the LED, the circuit is open, and I have my test probes from the multimeter connected in between that open of the circuit. So now I need to set my multimeter over to DC amps, and this symbol here, the straight line next to this capital A, means that this is to measure amperage in the circuit for DC circuit. And I'm going to put it to 200 milliamps, the 200 M here. So I'm going to turn from off to 200 milliamps right here. I'm going to turn on the circuit now, so I'm going to turn the switch on. You can see the LED is lit up, and I'm getting a reading of 6.4 milliamps. So if I turn my calculator on and we look back onto Ohm's law, 6.4 milliamps is written 0.0064 amps. So 6.4 milliamps is the same as 0.0064 amps. I'm just changing the unit size. And if we remember from Ohm's law, V equals IR, so I is the current, and that's the current that we're reading, the 6.4 milliamps or 0.0064 amps. And I multiply by the resistance in the circuit, which we know is this 1000 ohm resistor, and I hit enter, I get 6.4 volts. So remember, a series circuit is a voltage divider. So the 6.4 volts is a voltage that's being dropped across the resistor. Now, if we turn this off and I turn the circuit off and I remove my probes and I put the LED back in the circuit again, and I'm going to turn the switch back on, the LED is on. I'm going to place my black probe, which is to my common of my multimeter. I'm going to place the red probe on the anode of the LED, and I'm going to turn. I want to measure voltage across the LED right now. So I set it to 20 volts because this is a 9-volt battery. Just like we did when we were checking voltage, I needed to set it to a higher voltage than the power source, and in this case I set my multimeter to 20 volts. I'm getting a reading of 2.75 or 2.76 volts. I'm going to use 2.76 volts. 2.76. I've entered that number into my calculator. And if I add the voltage that we received by doing the calculation from the current that we measured and the resistance that we have in the circuit, this 1000 ohm resistor, if I add these two together, the 2.6 volts I'm reading across the voltage drop across the LED, plus the 6.4 volts we measured earlier, that's 9.16 volts. So if I remove the probes from the multimeter, and just like I did when measuring voltage, if I place the orange probe on the positive side and I place the black probe on the negative side, and I place my black probe from the multimeter on the black jumper wire, and I place my red probe from the multimeter onto the orange jumper wire, I get 9.05 volts, about that, which is, it's a little off, but it's very close. But it's pretty much on par. We're only off about 1/10 of a volt here, which is not a big deal. It's basically about the same. We're using a 9-volt battery. We get 9 volts. So we can see that how we check the current, we can use the current reading that we have and then the resistance that we know in this circuit. We multiplied those two values together using Ohm's law to get the voltage. And we measured the voltage drop across the blue LED, which gave us a voltage drop of 2.76 volts. And recalling that a series circuit is a voltage divider, we have a voltage division across the blue LED and a voltage division across the resistor, since these are the only two components in this circuit. And we add those two voltage drops in our circuit together, and we should get the voltage supply, which is about 9 volts.